So, hello everyone, I'm Yash, and this is the fourth experiment for ECE 505, that is Intro to Embedded Systems. The fourth experiment is regarding analog to digital conversion, ADC, and interrupts. So, this is the CCS workspace, that is workspace 2025 ECE 505. The experiment 4 is made here, and I have included UART, added the file UART stdio.c and also included drivers lid.lid. Here in properties, in include option, I have also added a path, and I'm using variant code for C series, Tiva C series, and this is Stellaris in-circuit debug interface. Coming to the code, I have included the main file and implemented the code, required code as per the experiment which was asked by our professor. And these are the included libraries. This is the initialization of LED red pen and LED blue, LED green pen to GPIO pin 1, 2, and 3 respectively. The switches are defined as SW1 is the switch pin, which is initialized with GPIO pin 4, and SW2 is initialized with GPIO pin 0. So this is the switch declaration of the switch interrupt handler and SysTick interrupt handler, init board, and init SysTick timer, void print temperature with time, init console, ADC init, and turn off LED void. So these were a few methods that we'll be using. These are the global variables which are initialized with the default value 0 for SysTick counter and seconds, and for CLK scale value it is 6. I have also initialized mm, ss, and ms as milliseconds, and as its default global variable, it will be initialized with its default value, which is 0. So first, let me come to the let me come to the init SysTick timer void. This is a SysTick timer initialization is done here. So the p second is the sysclock get functions, whatever the sysclock get function return, syscl clock get returns, that is 80 megahertz, will be stored by this variable, and as it corresponds to 1 second, so I'm dividing it by 1000 to convert it into milliseconds, which is like 1 millisecond interrupt is corresponds to 8000 cycles, as 1 second is 80 megahertz, 80,000 cycles. This is SysTick enable, which enables SysTimer, and this is SysTick period set, which set the trigger for every 1 second. This is the register initialization, that is the register for ISR, that is interrupt service routine, and I have enabled the SysTick interrupt here, and as soon as this is called, it generates, it triggers the ISR every 1 second. So this is called every 1 second, every 1 millisecond, and this is SysTick underscore counter plus plus. So as the variable was initialized as 0, so every time the function or the interrupt ISR is called, that is the interrupt service routine. So whenever it is called, the SysTick counter is increased by 1, that is added every time, and if SysTick counter is greater than 1000, that is 1 second, so the second is increased and the SysTick counter is reset to 0. And this is how the second, minute and millisecond is calculated. It is always keeps on increasing as the SysTick interrupt handler is called every 1 millisecond. So then this is also an important important method. So this displays the onto the terminal the values of that is the minutes passed, seconds passed, milliseconds passed, and the temperature at that point. So I'll be building the project. So as you can see, there is no error. And now I'll debug it. As you can see, I have connected this to COM3, my launchpad to COM3, and now I'll connect it. The baud rate is set to 9600, and as soon as I hit resume, the code will run. And as you can see, it is giving the values almost every 1 second. And if I'll blow some heated air onto it, so the temperature will rise. As you can see, the temperature is now 25 degrees Celsius. So I'll now disconnect and clear the data of this, stop the program from running, and now we'll be coming to the init board function. So this function initializes the system clock, the GPIO initialization as well, that is enabling the port F, and then it manually sets the PF4 port with this hexadecimal number, and after this, the GPIO port in type output, this enables the red and blue pin, and this set the red LED, blue LED and green LED as the output pins, and this sets the input pin as SW1 and SW2, which were initialized on the top using the pound define initialization. So we have also included a pull-up register for switch. So as soon as it is now coming to GPIO type set, this is a set interrupt for rising edge. So we have initialized SW1 and SW2 as the rising edge. It accepts only when the button is released after pressing, rather than the falling edge, which is the when the button is pressed, it will be counted as an interrupt. Then the register is set with switch interrupt handler, and the interrupt is enabled for both switch SW1 and SW2. So after this, we'll be heading to this part of the program, which is the function switch interrupt handler, that will be called whenever there is a press in this, when the release of the switch. And here we have include initialized int status as UART 32_T and LED as well with the same data type. So what in status do is like get the it gets the value whenever we press the switch, any of those switches, and if the switch is pressed, so now we can easily find that which switch is pressed. So if int status and switch 1 corresponds to the same value, so the AND of it, both of them will give the switch 1 value. So we have compared it with switch 1, and if this is true, then int status equals to SW1, that is the status. Int status will be switch 1. We have initialized int status with switch 1. And similarly, if this isn't true, so the other case could be if the switch 2 is pressed, and if switch 2 is pressed, then this will be true and it will initialize the int status with SW2. Now we have also cleared the GPIO port base, that is, we have cleared the flag that is int status. Clearing the flag will help the microcontroller know that an interrupt, like if this status isn't clear, the interrupt will be called again and again. So to stop that, we have cleared the status here, and after this we have checked if the status is SW1. So if SW1, that is the switch 1, is pressed, then we have cleared, or we have switched off the LED green and set LED as LED blue. And if switch 2 is pressed, then the blue LED is cleared or like turned off, and the LED is switched to the LED is initialized with LED green. Now GPIO pin right will give a high output to the LED, that is chosen LED, that is if it is LED blue. If the switch 1 is pressed, meaning after pressing it will be released, because we have used the rising edge rather than the falling edge. So if the switch 1 is pressed, then the blue LED is turned on, and if the switch 2 is pressed, the green LED is turned on and the other LED is turned off. And now I'll be building the whole project up. I think I've included and explained about all the functions. Init board, yes. Temperature, yes. This is the main function. In this there is an infinite loop, and here we have called the print function to print the values as it changes in its whole ADC end. Yeah, I've completed explained about all the things that I've done. So now we'll build the project. So as you can see, it is built. I am going to debug it. So the code is loaded onto the microcontroller launchpad rather. I have the the terminal here. I'm connecting it to the terminal, clearing the values of the input, the terminal, and now I'll resume. So as you can see, it is giving the temperature, but at the same time there isn't any LED blinking here. As soon as I hit switch 1, the blue LED will turn on. If I'll again press the switch 1, the blue LED will be reset, but it won't turn off. Now I'll press green LED, the switch 2, and it so the green LED is turned on. So how the rising edge works is when I press it, as I have pressed the button, that is the switch 1, it isn't changing the color of the LED to blue, but as soon as I'll release it, it will change the color to blue and turning off green LED. So as you can see, this happened. And similarly goes for switch 2. So as I have pressed it, it isn't changing, and as soon as I release it, it's changed to green. So this is the conclusion of the experiment, and I have learned how to use interrupts, code and ADC, use the internal resistor of the launchpad to give the temperature readings, also use the system clock to give the time that the code has run. Thank you. I also wanted to show that the data that I received from this onto the terminal is printed onto the sheet, is pasted onto the sheet, and I have used text to table converter, and that's how I assign all the values as separate columns. This is the temperature column, this is the millisecond, this is the second, and this is the minutes. And I have taken data for 1 minute, 14 seconds, and 137 millisecond, and the temperature goes to 27 degrees Celsius. I have used this Excel sheet as an input to the MATLAB code. Then I have separated or extracted the minutes, seconds, and milliseconds, and extracted temperature column as well. And the time second, second is calculated, the overall time in second is calculated, and it is plotted. So as I'll run it, this will be the graph that you can see, which is temperature in degrees Celsius versus time.